All right, welcome. Today, we're going to dive deep, and I mean really deep, into the very foundation of our digital world. We're going to follow the incredible journey of a single bit of data as it travels across a network.
I mean, have you ever really stopped to think about it? You hit like on a photo, you fire off an email, you stream a movie. What is physically happening in that moment? It honestly feels like magic, right? But it's not. It's just an absolutely brilliant feat of engineering.
And the answer to that question, well, it all starts at the very bottom, at the foundation of the entire network, the physical layer. This is that crucial spot where purely digital information has to become a real physical thing in the world.
Okay, let's get into it. Before a single bit of your data can go anywhere, there has to be a physical connection. Whether that's a wire or just the air itself. This is the unseen foundation that absolutely all of our communication is built on.
So here's the deal. The physical layer's main job is to take a complete package of data. It's called a frame. Think of it like a digital envelope with your message inside and translate it. It has to translate it from the language of software into the language of physics into a series of signals that are ready to be sent out into the world.
So how does it actually do that? Well, it really comes down to two key jobs that are super related: encoding and signaling. Let's break those down.
First up, we've got encoding. The best way to think about this is like a secret code. The physical layer takes that raw stream of ones and zeros from the computer and arranges them into a specific, recognizable pattern. It's a format that the device on the other end is expecting, so it knows how to read it. And then there's signaling. And this is where the real magic happens. Signaling is the method of physically representing those ones and zeros. So if encoding is the secret code, signaling is how you actually send it. It's like using a flashlight to blink out Morse code. This is the moment that abstract bits become a physical reality. And that physical reality really comes in three main flavors. We can send these signals as little pulses of electricity down a copper wire, as pulses of light through a super thin glass fiber, or as microwave signals zipping right through the air. Let's take a look at each one.
We're going to start with the one you probably know best: copper cabling. This is the absolute workhorse of modern networking. You'll find it in pretty much every home and office on the planet. But sending electrical signals down a tiny copper wire isn't so simple. Engineers ran into three huge problems. First, there's attenuation, which just means the signal gets weaker and weaker the farther it goes. Then there's interference from all sorts of other devices. That's EMI and RFI. And finally, you've got crosstalk, which is when the signal in one wire actually messes with the signal in the wire right next to it.
And this is where the genius of network engineering really shines. To solve these problems, they came up with some incredibly clever solutions. They put strict limits on how long a cable can be to fight that signal fade. They added metallic shielding to literally block interference. And my favorite one, they started twisting pairs of wires together. It turns out the magnetic fields from the two wires actually cancel each other out, which is just a brilliant way to get rid of that crosstalk.
In fact, if we could just crack open a common cable, you'd see all of this in action. Right at the very center, you have the copper conductor that's carrying the signal. That's wrapped in plastic insulation, and then, this is the important part, it's surrounded by a woven copper braid. That braid is the shield we were talking about, physically blocking any outside noise from messing with your data. So simple, but so effective.
Okay, so that's copper. But what if instead of using electricity, we used light? Well, that brings us to the world of fiber optics, the undisputed high-performance champion of network cabling. And right here, this is fiber's killer feature. Because it's using light instead of electricity, it is 100% immune to all that electrical and radio interference that gives copper cables so much trouble. And the performance? Oh, it's just staggering. We are talking speeds of up to 100 gigabits per second. To put that in perspective, that's fast enough to download dozens of HD movies in a single second. It's this mind-blowing capacity and its ability to go for huge distances that makes fiber optics the backbone of the entire global internet. We're talking about the massive cables laid on the ocean floor connecting continents. Now, not all fiber is created equal. There's a bit of a trade-off. You've got single-mode fiber, which uses pricey lasers and has a tiny core, but it can send a signal for miles and miles. That's perfect for those long-distance networks. Then there's multi-mode fiber. It uses cheaper LEDs and has a bigger core, which makes it way more cost-effective for shorter runs, like wiring up an office building or a campus.
Which brings us to our third and final way of sending data, just beaming it right through the air.
Now, wireless gives us incredible freedom and mobility, but it definitely comes with its own unique set of physical challenges.
I mean, unlike a cable, wireless signals get blocked by walls and other stuff. They can get totally disrupted by everything from your microwave oven to a cordless phone. Security is also a huge deal, because literally anyone nearby could potentially listen in on the transmission. And finally, everyone in the area is sharing the same airways, so the more people connect, the slower it gets for everybody.
So there you have it, our three options: copper wires, beams of light, or invisible airwaves. The big question for any network designer is, how do you choose the right path for your data to take? Well, this chart here really makes the choice crystal clear. You look at it, and fiber is just vastly superior in speed and distance, and it's totally immune to interference. But then, you look at the cost and the skills needed to install it. Copper is so much cheaper and way easier to work with. It's a classic engineering trade-off, really. Pure, raw performance versus cost and practicality.
And that really gets us to the main takeaway from all of this. There is no single best medium. There just isn't. The right choice is always a balance. It completely depends on what you need for that specific situation. Are you prioritizing raw speed, extreme distance, low cost, or is mobility and convenience the most important thing? Every scenario demands a different physical solution.
So every like, every email, every video you stream, it's a journey that starts on this physical foundation of copper, glass, and air. These materials literally built the digital world we live in today, which kind of makes you wonder, what materials are going to build the world of tomorrow?